Hey everyone, in this video I will share the most fascinating things I learned in my time with cosmology so far. These ideas will blow your mind hopefully and show you what cosmology is really about. What is cosmology? Cosmology is the study of the whole universe, like its origin, structure, and how it's going to end. It's different from astronomy since it's looking at the big picture. It theorizes how the universe started and how it will change over time. What are the subjects involved in cosmology? Chemistry, physics, and astronomy. Let me tell you why. Physics. Physics, general relativity, describes how gravity shapes the universe on large scales. Quantum mechanics. It is needed for understanding the early universe, the particles, and the fields. Nuclear physics explains the Big Bang nucleosynthesis. Astronomy. What does astronomy have to do with cosmology? Well, the three main topics for observational data are telescopes, spectroscopy, stars and galaxy observations. Telescopes collect light from distant galaxies, stars, and the CMB. The CMB, we will talk more about it later. Spectroscopy measures redshifts. Redshifts are used to measure how far away things are, helping determine the universe's expansion. Star and galaxy observations. They help the universe's structure and history. They help map, Chemistry. What does chemistry have to do with cosmology? Well, cosmology has elements in it, like hydrogen and helium when the Big Bang happened. Big Bang elements. Chemistry explains how hydrogen, helium, and lithium formed right after the Big Bang, like I was just saying. Star and galaxy formation. Chemical reactions help gas clouds cool and collapse into stars and galaxies. Supernova explosions. They explode heavy elements like carbon, iron, and gold across the universe, which are a bunch of periodic elements. Planets and life. Chemistry helps shape planets and helps us find conditions that could support life. Space observations. We analyze light using chemistry to know what stars and planets are made of. Equipment and technology that was used to gather information for the Big Bang. This is the Planck. Scientists figured out the Big Bang theory using a mix of observation and physics. Telescopes show that galaxies are moving away from us, like redshift, meaning the universe is expanding. Spectroscopes revealed this through redshift, like I was just saying. Then, radio telescopes picked up the CMB, the cosmic microwave background. It's like a big map of the universe. The leftover glow from the early universe, like I was just saying. Einstein's theory of general relativity and later math models supported the idea of a universe that started small and grew. We'll talk more about that later. Satellite missions like the Planck is just one of many of the satellite missions that map the CMB and confirm the Big Bang's predictions. We are moving on to the Big Bang. It's one of cosmology's biggest topics. The idea behind the Big Bang is that it happened around 13.8 billion years ago, according to the waves that they calculate using math, redshift waves. They believe the universe came from a tiny, really hot state or a primeval egg. Like that red dot over there. I will read you the timeline. The Big Bang, at time zero, the universe was concentrated into a single tiny primeval point or infinite temperature and density, full of infinite temperature and density. In an instant, space began to expand rapidly. This is known as a cosmic inflation. It says right there, cosmic inflation, right here. As the universe expanded, it cooled, allowing energy to convert into subatomic particles, which like protons, neutrons, and electrons. Over time, a few minutes, nuclear fusion formed light elements such as hydrogen and helium. has to do with chemistry. Hundreds of thousands of years later, the universe cooled and started forming. They cooled enough for atoms to form, leading to the release of CMB radiation. A faint glow still observable today. Over billions of years, gravity pulled matter together to form stars, galaxies, and eventually Earth-like planets. Three main factors proving the Big Bang: primordial nucleosynthesis, Hubble's discovery of redshift showing galaxies move away, and the CMB, the cosmic microwave background, that is like a fossil skeleton of the Big Bang. What is primordial nucleosynthesis? It's the observed amounts of hydrogen, helium, and small amounts of lithium in the universe. These match the theoretical prediction for what would have been produced in the first few minutes of the Big Bang, like shown on the timeline of the universe. The Big Bang model correctly predicts that about 75% of the visible matter should be hydrogen and 25 helium by mass. Exactly what we see. Redshifts of galaxy. What is a redshift? Light from distant galaxies is stretched, also known as redshifted, indicating or showing that they are moving away from us. It matters because it shows that the universe is expanding, as predicted by the Big Bang Theory. Redshift is how we know the universe is expanding. Who discovered redshift? Edwin Hubble observed this in the 1920s. The further away a galaxy is, the faster it appears to be moving away. Just what you expect to see from a universe that started in a single explosive expansion. This is the CMB, the fossil skeleton of the universe. Why does it matter? This is the leftover heat from the Big Bang. Essentially, also known as the afterglow of the early universe. This is what it looks like cooled after billions of years. Who discovered this? This was discovered by Arnold Penzias and Robert Wilson in 1965 accidentally while investigating radio signals. Who are the essential people who have contributed? Who are the most important people who have contributed to the Big Bang Theory? Georges Lemaitre. He was the father of the Big Bang Theory. He proposed the idea of the primeval atom, the first formal version of the Big Bang in the 1920s. Who's one of the other most important people? Edwin Hubble. He provided key evidence. He discovered that galaxies are moving away from us, also known as redshifting, proof of that the universe is expanding. Albert Einstein. He laid the foundation. He was inventor of general relativity. George Gamow. His role was early Big Bang supporter. He was an early Big Bang supporter. His contribution was that he predicted that a hot, dense early universe should leave behind cosmic microwave background radiation, the CMB. That was George Gamow. Arnold Penzias and Robert Wilson. They are the accidental discoverers, which I learned in class. They detected the CMB in 1965 while working on their radio station, giving strong evidence that the universe began in a hot, dense state. These two ran across a talk that was happening, and the scientist that was talking about it found out later that what he was talking about had happened to do with those two. Alan Guth. His role, he developed inflation theory. He proposed cosmic inflation. Those six are really important people who have contributed to the Big Bang Theory. Let's move on. Other theories showing the Big Bang might be wrong. Well, the two most important ones is one I learned in school and one that I ran across. The steady state theory. We talked about this in Mr. Cummings' class when the older theory claimed the universe has always existed and is constantly creating new matter. It fell out of favor after we discovered the CMB, something it can't explain. I don't think that's true that the universe has always existed. Something might have had created it. A Big Bang or something else that we might not know of. The cyclic universe. This is an idea that says the universe goes through endless cycles like bang, expand, crunch, and repeat. It sounds weird, but it challenges the idea of a one-time being. But we found no evidence of past cycles yet. These are two, but I think there might be a Big Bang or something else that might have created it. Let's move on. Dark matter and dark energy. Something I've learned on my own. What I've learned on my own about it. 90% of the universe is invisible to us. Dark matter doesn't emit light. Dark energy makes the universe expand even quicker and quicker. Dark energy is like stuff surrounding the earth. Dark matter is 27% of the universe. It's invisible mass that doesn't emit, absorb, or reflect light. We know it's there because of gravitational effects on galaxies and clusters. One of the key evidences are these two galaxies. On the left, we have a model of a galaxy that only includes the stars and gas we can see. Notice how the rotation speed drops off the further you go from the center? That's what we would expect based on visible matter alone. But on the right, the model includes something extra, a halo of dark matter. With that added in, the rotation speed stays high, even from the center. This matches what we actually observe in real galaxies. This big takeaway here is without dark matter, the math doesn't add up. Something we can see is affecting how galaxies spin, and that is one of the main reasons we think dark matter exists. One thing I forgot to add is that dark matter is not made of atoms and not black holes, planets, or ordinary gas. We're moving on to galaxy rotation curves. Stars and galaxies orbit faster than they should based on visible mass, according to this data right here. I'm not really sure about this, but if you detail more into it, you would know. But these are one of the topics of dark matter. This is a bullet cluster, a famous collision between galaxy clusters that show normal matter separating from the mass, proving dark matter really does exist. Let's move on to dark energy. This is a supernova, type Ley supernova actually, or supernovae you may say. What is dark energy? It's 68% of the universe. A mysterious, or you could say repulsive force that causes the accelerated expansion of the universe. We don't know exactly what it is, but it could be what scientists say a cosmological constant or a dynamic energy field. Key evidence, like I was saying, a type Ley supernovae. This is used as a standard candles that show the universe's expansion is speeding up. Let's move on to another key evidence. If you would let me. 1 second. dark energy and matter making 95% of the universe. As this chart shows, the combined impact of these two is dark matter holds the universe structure together, while dark energy pushes the universe apart. Combined, they make up 95% of the universe, meaning everything else we see, like stars, planet Earth, sun, whatever you want to say, is just 5%. That's pretty crazy if you think about it. Shape and possible fate of the universe. Is the fate going to be a big freeze or something even bigger? Nobody knows yet. When cosmologists, scientists are talking about the universe, they're talking about the shape of the universe, also known as the curvature, how space bends under influence of possible dark energy, mass, and energy, like dark energy, and how geometry works at cosmic scales. There are three possible outcomes of what the shape of the universe could possibly look like: a flat universe with zero curvature at all, a closed universe with positive curvature curving out, and an open universe with negative curvature curving in. Shape is about curvature. Topology is how space might be looped or twisted, that you could say, and it's possible that the universe is flat, but it might be multiply connected like a donut in a circle. So if you traveled far enough, you might be able to return to where you came from. Scientists are still figuring out, but right now we know that the universe looks really flat, or what the scientists say, homogeneous. What are the fates of the universe? Well, I showed you four, and we'll talk about them. The first one on the top left is the big freeze. The universe keeps expanding and stars burn. What happens is the universe keeps expanding forever, and galaxies start drifting apart and stars burn out, and no new stars form. Eventually, everything becomes and reaches at a cold, dark state with no usable energy because there's no stars, right? The end result, a dark, cold universe where entropy, also known as disorder, which I searched up a fancy name for, is maximized. Life becomes impossible, right? The big rip, the one on the far right, it means dark energy gets stronger and starts stretching across the universe. So it could tear the universe apart. First, galaxies get pulled away from each other. Then the stars, planets, and even atoms could be ripped apart. And that's not good. Because if you rip up atom, that creates a huge explosion. We do not want that. As a result, the universe literally tears itself apart in a finite time, a really fast time. The big crunch on the bottom left is this one. What happens is if the universe's density is high enough, expansion could stop and reverse. Like reverse. It's not good. Everything collapses back into hot, dense point like the primeval egg and possibly leads into a new Big Bang. End result, the universe ends in and collapses, potentially starting over. That sounds really weird. The big bounce on the bottom right, the final one. On this one, what happens? The universe expands, collapse, also known as Big Crunch, then bounces into a new expansion. Suggests the universe has infinite cycles of birth and rebirth. End cycle, eternal cosmic rebirths, but still hypothetically. This was one of the theories we talked about earlier, why it might be fake, the Big Bang. Well, thank you for watching my video, guys. Cosmology has completely changed the way I view the universe, and well, this is my favorite subject in science. I've had 2 weeks to learn about it, or probably more, and I really enjoyed the time I've learned about this in Mr. Cummings' class, and it's changed the way I see the universe, and it gives me sort of an idea where we could be heading or where we're not heading, and it's really awe-inspiring. If you like this video, please hit the like button, subscribe, and drop a comment with what fascinates you most about the universe. See you next time. Here are the links that I used to help.